Morning, everyone. Hi, Leandra. So, a reminder, our exam is this week, Friday, based on, let me actually tell you what will be in the exam first. This time, I'm not going to do a review myself. I'll just give you some questions to do. You're going to do the review by yourself. I think you can go in person. They don't have anything online in person. Wow. Huh? Walking. Oh, wow. Good. Let me tell you what will be in the exam. There will be two questions from here. From addition subtraction. One of them will be like terms, one of them will be different denominators. Two. Also, there will be two solving. One question from here. So study all three. You just see one of them. Which one? I'm not going to tell you. One. And if I have space, then probably two. Otherwise, one. Complex. One or two, depending on space. If I have space, then I'll do two. If I don't have space, then one. But definitely one. Two of them. Definitely one with the joint and one anything else. One from, sorry, not one, two. Two from this. One distance, one midpoint, but that one has two parts. In one part, you're going to state the formulas. And in next part, you're going to find the distance and the midpoint. So two questions, but four parts. Addition and subtraction, one. Multiplication, two. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 or 16. Okay. Probably I'll put all the multiplication under one. For example, here, we have two types of multiplication. One is this, see all of these are multiplication. So maybe I'll put question one and then multiplication, four of them. Because they all are multiplying and simplifying. So why do you want me to write four of them for four parts? One question, four parts. But total, including everything, 15 or 16. So from this type of multiplication, you're going to do two of them. From number 3, you're going to do two of them. So you must do four of them, but maybe I'll put one question, multiply and simplify, and then four questions. In that, I don't have to keep writing multiply, simplify, multiply, simplify, multiply, simplify. Because we have one direction, but 4 type of questions. So one heading, but 4 questions. Huh? I didn't hear it. Multiple choice. I don't have any multiple choice. But just like the previous exam, the last exam, 1 page, you have partial credit, 3 pages, no partial credit. Just like final exam. Robert, Robert, Eddie. Two from addition subtraction, 2 from solving, 1 from word problem, and one or 2 from complex. So definitely 2, 4, 5, 6, definitely 6. If I have space, then 7. Any other question? So my plan for Thursday is not going over everything myself, but I'm going to give you the questions and you are going to work and see where do you have problem. So that the next day, in the exam day, you'll prepare yourself by solving what you don't know before on Thursday. Okay? Because I realized me doing the review didn't help you much in the last few exams. So, huh? I helped. But all I did was doing the same question I did in class. So if you don't know, understand anything or don't know anything, just go over the lecture videos because I posted everything. So that's why instead of me doing the work, I want you to do the work so that you can see where you have problem, which needs to be fixed before Friday. Okay, so let's do something different and see how the result goes. But I already told you what will be in the exam. So you just have to study those questions, those type of questions. And one of these definitely will be in the exam, addition and subtraction. And there was a final exam. So actually most of the question you'll see in this exam, you'll see them again in the final exam, most of them. Question in the last class, but I didn't go over, right? I told you to do them, but I didn't have time to going over. So let me do them fast, and then we are going to learn something new. Leandra, you want me to help? No problem. Only the answer? No, tell me in details, fast step. Uh-huh. 9 and 2. So we have square root of 4 and square root of 2. It doesn't matter, but I like to have my simple, the perfect square first so that I can multiply easily with the coefficient. The last one is not simplificable, so we cannot break it down. So what do we have? 4 times 3, radical 2. We have the exact same 2 things. Any question? Medicine? No? Catherine? Is it? Is anybody lost in any of the step? Attendees. We have positive 12 root 2 and negative 12 root 2. Are they like terms? They are like terms because they have the exact same radical with exact same inside. That means you add or subtract their coefficients. We have positive 12 minus 12. What is positive 12 minus 12? 0. That's why they cancel out. Any other question? Anybody would like to help me with the next one? Mohammed, Leon, they already did one. 16 and 5. And 45 is 9 and 5. Mm-hmm. So this gives us 8 square root of 5. This gives us 27 square root of 5. Total, we have negative 19 square root of 5. And these are like terms because we have the exact same variable, so the exact same root radical with the exact same inside. And for this type of question, if you don't know which number to break it down, like 80, how do you know it's 16 and 5 you have to use? If you don't know, you can always start with a smaller radical. 45 is a smaller radical, and when you break it down, there's only 2 choices, 9 and 5. So when you break down in 45, you know that definitely the unsimplified number has to be 5. So it means you need to divide 80 by 5 because you want to have the same number inside the radical. That is not simplificable. The unsimplified number must be same. If they are not, that means you cannot combine them. Now we have 24 and 54. Anybody would like to help me with this one? You already did one. Let other give another chance. You also did one. Who is completely confused? Anybody? Tahsin, you help me with this. You look confused. Okay, step 1, break down 24 into 2 numbers. One must be perfect square, another is not a perfect square. Do you know what perfect square numbers are? 1 square is 1, 2 square is 4, and then what else we have? 8 is not perfect square. No, perfect square means you multiply the same number twice. So 3 times 3, what is 3 times 3? 9. Then 4 times 4, what is 4 times 4? And then 5 times 5. 25. Okay, now 24 is divisible by which of these perfect square number? 4. 4 times what is 24? 6. That means you need to divide 54 by which number? Definitely by 6. So 6 goes to 54 how many times? 6 times what is 54? 9. See, if you don't know which number to pick, start with a smaller number and then divide the bigger one by the unsimplified number. So we bring down our 5 and we bring down our negative 11. What do we do after that, Tahsin? We have our 5, and what do you have from here? 2. We have our 11, and what do you have from 9? 3. So we simplified our radical, and then what? 10 radical 6, and from here 33 radical 6. Total how much? Positive or negative? Negative 23 radical 6. Oh. Got it? Send this. No, 6 is not a perfect square number. Or 6 doesn't have any perfect square number. It means you cannot divide 6 by 4 or 6 by 9. For square root. When you have a square root, you need to divide by perfect square number. The perfect square means the same number multiplied twice. Like 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. These are perfect square number. So your goal is to divide your radicand by the highest perfect square number that is divisible by that. Okay? Any question? Actually, let me go over one more question where you don't have the same perfect square number. Sorry, same unsimplified number. You may see it in the homework. Something like, let's say, have square root of 32, square root of 8 minus square root of 27. And let's say we have 2, 3, 5. Which one is the smallest radicand, smallest inside? So let's start with 8. How do you break down 8? 4 and 2. That means you want to divide the other 2 by 2, if it's divisible. Can you divide 32 by 2? How many times? 16. Can you divide 27 by 2? That means these 2 will be like terms, but this one will not be like terms. So you need to look for a different perfect square number. 9 and 3. So square root of 9, square root of 3. We bring down our coefficients to -3, -5. I am not sure. So 2 times what? 4 square root of 2. 3 times 2 square root of 2. 5 times square root of 3. 3 and 4 gives us 8 square root of 2. 3 and 2. 6. 5 and 3. 15. Now, do you have any like terms here? Only these two are like terms, right? Because they are the exact same radical width inside. So we combine their coefficients. What is 8 minus 6? 2 radical 2. Can you combine that with -15 radical 3? No, because even though we have the same root, but we don't have the same inside. So it's simply bring it down. They're not simplificable anymore. Cannot combine them anymore because they're not like terms. Not like terms. Because you took the square root, That's why 16 becomes 4. They cannot have any more roots. Square root of 16 is 4. That's square root of 16 is square root of 4. No? Okay. But this is a common mistake. People take the square root but keep the square root again. I've seen it to many students. So see, not always you're going to have one term at the end. Sometimes you have two terms or more terms if they're not like terms. Question? Okay. So now we are ready for another multiplication. We did one type of multiplication where we multiplied a monomial by a monomial. Now we are going to multiply, not a monomial, but monomial by binomial or binomial by binomial. Monomial means one term, binomial means two terms. So when you multiply, we multiply just like normal multiplication. How do you multiply that normally, usually? Distribute. So we distribute the 5 to the binomial inside. We have 5 times square root of 2 minus 5 times 3. So 5 square root of 2 minus 15. And that's it. Yes. So we can multiply 5 and 3, become 15, because both of them are free. But we cannot multiply 5 with the 2 inside, because the inside 2 is underage. Remember? They're underage, they cannot go outside. So they have to stay inside, and the 5 is an adult. It has to go outside to work. So adult stays outside, the underage stay inside. If they don't have the same ridicule, we cannot combine them. We just have to put them together. Okay? But here, 5 and 3, they both are adult. Yes, they can combine. Question? That was easy, right? Now, what if we have a radical? So we are combining 3 underage elements. Well, no problem. We start by what? Distribution. So you take the first element, we multiply by the monomial. Then we go to the second term and we multiply by the monomial. So square root of 6x times square root of 6 minus square root of 6x times the square root of x. Sorry. And now they become just like the multiplication we did before. Do you remember the multiplication we did before? When you have a number and variable, what do you do when you multiply them? We have two of them. Inside, we put 6 times 6 and x. So we separate them. And we have 6 x times x. When you multiply number and variable inside the radical, split them so that you can see how each of them can be simplified. Now 6 times 6, what do you get? 36. So square root of 36 times square root of x minus square root of 6 times x squared. So you multiply the numbers, you multiply the variables, and now it's time to simplify. Do we know what is square root of 36? 6. Do we know what is square root of x? So we keep it. Do we know what is square root of 6? Keep it. And how about square root of x squared? Good. The square root and square cancel out. So left to it the single x, 3x. And they're not like terms. Because even though we have the same radical, but now inside are different. They cannot combine them anymore. We stop. than this. We cannot, because remember, you have to add and subtract. There are two conditions. Same radical and same inside. We have the same radical square root, but do you have the same inside? So you cannot combine them. Leandra. Because when you multiply the numbers and you multiply the variables. So these two are the numbers, but there is only one variable. You single it out. Here we have only one number, but two variables. We put the variables together, but the number is singled out. Huh? Huh? Linda, what? You have to combine the radical. Numbers goes with numbers, variables goes with variables. The directions is multiply and simplify. So we multiplied here, but when you multiply, we see two scenarios. One has number variable and one has number. So just like before, when you multiply number and variables, you multiply the numbers and multiply the variables and simplify them separately. So when you multiply the numbers, we get 6 out. When you multiply the variables, you get X out. So for example, previously we did this. Square root of, let's say we have 8x and square root of, let's say we have 6x squared. So previously what we did, we wrote, okay, it's 8 times 6 inside one radical and x times, let's say this is cube. X times x cube is inside another radical. And then you guys don't multiply, instead simplify. So 8 is 4 times 2 and 6 is 2 times 3. So we have square root of 4, square root of 2 twice, and square root of 3. Do you remember doing that? What is square root of 4? And what is square root of 2 square? Also 2, because the radical and square cancel out. And what is square root of 3? We bring it down. So we get 2 times 2, 4 radical 3. We simplified the number and we got 4 radical 3. And here we have square root of how many x's? 4. And then we said if it's divisible by the index, we have solution. We have only one solution. But if it's not divisible, we break it down into 2 pieces. So is 4 divisible by 2? So 2 goes to 4 how many times? Twice. So we have x squared. If it wasn't divisible, then we would have break it down into more pieces. So this is the same thing here. We have two numbers. We put them together in one variable, a still variable, so it is a separate house. Here we have two variables. We put them together under one house. And there's only one number. We put them together inside one house. And then it's simplified just like we simplified before. Because here you're multiplying them. So here you put the 6 from here and radical x from here. They are multiplying, so you put them together. On this side, you have 6 radical and x squared square root becomes x, so you put them together. And then this multiplication become addition and subtraction. But in addition and subtraction, we do get 2 conditions. Same index and same radicand, same inside. So it failed to the next requirement. Question, who raised hand?
So you multiplied 6, but for the other one, that's one. Not 8.
Because 8 times 6 is 48, and do you know what is square root of 48? No. But do you know what is square root of 36? That's right. When you don't get a perfect square number, don't multiply, break it down. But when you do get a perfect square number, you don't have to multiply. So you don't have to break it down. You can multiply or you can put 6 square. Then they cancel out. Good questions. Any other question? Now let's do binomial times binomial. They look bad by same thing as the left page. You just do it twice. So you take the first term in the first binomial and multiply the entire second binomial. So we have 4 radical 2, and you're multiplying 3 radical 2 minus 4. Huh? I'm not done. So you split them. First, I took one of them, multiply the entire second one. Then you take the second element and you multiply the entire second term. So plus 7 times 3 square root of 2 minus 4. So it's exactly same as the left page, but you have to do it twice. So go to the distribution. We have 4 radical 2, we are multiplying 3 radical 2. 12, and how many radical we have? How many radical 2 we have? 2 of them. And what happens to the square and the power? Cancel out. Radical 2, radical with the square. So we get 12 times 2. And what is 12 times 2? 24. So only the first multiplication of the first 2 terms gives us 24. Let me change color and go to the next one. We have plus 4 radical 2 multiplying by negative 4. There are only one radical, right? So we keep our radical radical 2, and we have this free number with this free number. So what do we do with the free and free? Adult and adult. What do we do to adults? Multiply them. What is 4 times negative 4? Negative 16. So the second term gives us negative 16 squared. And let's keep it down. Negative 16 squared root of negative 16. No, never mind. The next time I'm going to combine. Let me change the color to green and do this one. We have 7 times 3 radical 2. So plus 7 times 3 radical 2. Plus or minus? Plus. Plus 21 radical 2. Let me change the color again to purple. The last one. Plus 7 times minus 4. Negative 28. So negative 28. And we have plus 21 radical 2. Do you see any like terms? Which two are like terms? 16 and 21. They have the exact same two things. Square root, square root. Inside the 2, inside is 2. So we combine their coefficients. What is negative 16, positive 21? Positive or negative? Positive 5 radical 2. And this 28, we have nothing to do, so we bring it down. Are we done, or we have more like terms? At the end, we have two more like terms. So when I combine them, what do you get? -4, 5 radical 2. And now we cannot combine them anymore because this 4 is free. It doesn't have any square root of 2. And this 5 is a square root of 2, so they're not combinable. They're completely different things. Brianna. Because we have 7 free and 4 free. See, 7 without any square root, 4 without any square root. So where will they get the square root? They don't have any square root to begin with. So single 7 and single 4. We multiply them, get single 28 without any radical. They don't have any square roots next to them. Who raised hand? I saw someone. No more question? So these are final exam question. It will definitely have one of these or two of these. Any question on this? Okay, then I have 4 questions for you to try. Let's see. I'll give you 10 to 15 minutes. Try them and then we'll do them together. What do you have next? Rationalizing. Okay. You don't have to work alone. Talk to your neighbors. Hear your ideas, your mistakes and everything. Learn from that. Let me take the attendance now. Brian Almonte here, Christina here, Catherine here, Jolene here, Govan here, Madison here, Eric here, Stephanie here, Leandra here, Robert here, Katie here, Kimelsa here, Sandy's here, Angie here, Mazavin here, Melville is here, Giselle here, Mohammed, Tahsin, Gavin here, Brianna, Texas here, Carla here, Yvette here, Nick here, Danielle. Oh man, almost perfect attendance, but only one is missing. Ah. Because we did. This one, this, and this one, the other. Oh, that's because one is right, and this one is here. That's not the no. I'm gonna be here to see. So you don't want to write it? Now your 5 is free and 4 is free, you multiply that 5%. And then your square root 7 and square root 7, if you exact simplify, so you write down the square root. The next one How many services? That's the 5 times 4 how many services? So you get 20 times. How many services do you have? One time plus six. This one. So, that's two. Then it's five, you understand. You know, you can get it right in there. Perfect. Question number 1. How many square root of 7 do you see? Then why do you only one of them?
They're hiding it like.
And then what happens to the square and square root? This is still this is the square. So combining them will give you
I got it.
How many services?
I do. Negative.
And why do you recommend?
Because remember the first time we created the file, I don't know, like, the file.
Only as a thing, you should go to the car. It's the same thing here. How many times?
Yeah, one thing is like.
But you know that 114. Okay, that's the multiple height. Now, 5 is that, 4 is that. For the vertical part, what you see? So when you multiply the numbers with the numbers, vertical thing. Yeah, that's me. Why would another person you agree? That's another person you okay, that's good. Perfect. Wonderful. Fascinating. Oh, look at everything.
Maybe you can talk to him. Are you helping?
So either. But they didn't want to.
You mentioned that as well.
Not something like. Thank you.
But you multiply them, that's what it's saying. And these are obviously correct. To see that I will be down zero number. I don't can find. Five, 7, and then number and very clear and very clear. So 5 times 4 is 12 to 7. Everything is 16 plus 3 25. 7. Yeah, what is the number here? Yeah, square root. We have 20 outside. This then inside. You multiply them.
Oh.
Do you have any class sign between them? What sign?
No, I got like 2 more lines, so.
And you said to do this.
Somewhere.
Oh.
We're trying to. I'm listening.
These are the top square. Oh, please. Good. Good. That's before square. But what do you have? Yeah, but what number you have? Then why just square here? Then why just square?
First and fourth, 13 for 3.
You just gotta think of so bad. Oh, yeah, I know, but. You could do it the way I just supposed to they like because I'm just so plus
Oh, yeah, you're right. It's not-
and then distance without.
Well, the whole thing is, when
Because I have cards for you. I don't know. Cards that go into my so looks something, yeah, it's like.
What do you think?
So it's the next one, so that's usually five.
Now, first you put number. Almost see, but it's crazy. Yeah, 5 years square, into 5 years square. 25. But exponent rules, a b square means a square times b square.
But it's can't be up there, right? But it's just, you get this.
Multiply your class 10.
No. I'm going back. So. So we need the 8 and. And 13. This is there's one. Yes. So I'm squaring. The book can square cast off. And then with the 5. It's the same thing as this.
You with this.
Why are you talking?
I'm gonna do it like.
You understand those ones? And shit. Let's hear me.
Like, it is something else. How do you do this? None of that twins are there. How do you twins? It's five.
Yes, you guys are 35, yes. They're the same.
Wow, it's training. Let's do them together.
Yeah.
Remember, definitely one of these will be in the final. Definitely. So, as we did before, we take the first element in the first binomial and we multiply the entire second binomial. This line is optional. If you are not used to writing this, no problem. Four radical 7 plus 2. Now, we have 5 radical 7 times the 4 radical 7 and then 5 radical 7 times the 2. Then we have 3 times 4 radical 7 and 3 times the 2. When you multiply the numbers with the numbers, radical with the radical. So 5 and 4, their numbers, we get 20. Square root of 7 and square root of 7, they're the exact same two things. So we get square root of 7 square. Because they're the exact same two things. In the next one, only 5 and 2 are the numbers. So we multiply them. And our 1 radical is square root of 7. We bring it down. The next one, only 3 and 4 are the numbers. And we have only 1 radical, so we bring it down. And lastly, there are no radicals, so we multiply them and we get the plain 3 adult 6. Now this radical and square root, they cancel out because they are the same. So we get 20 times 7, which is 100, 340. If you don't know how to find them, it's, sorry, 140. Oh, because in my morning class, I did 17 instead of 7. So my brain is still stuck with 340. There are 140 here. These are like terms when you add and subtract because we have the oops. We have the exact same radical with the radicand inside. So we combine their coefficients and we get negative 2 radical 7. 6 is alone, we bring it down. And now 6 has a friend. We put them together. How much we have? 134 minus 2 square root of 7. Any question? The next one is same. I'm too lazy. Can you just give me the answer? What's the answer? 18 or 16? How do you start first? What? 38? Okay.
48. What?
48?
13. You want the answer? What do you want? 13 plus 18 plus 18. 13 plus 18.
13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 plus 18. 13 13 plus 18 square root of 6. If you don't get the answer, you can ask me later. Let me show you this one. This one is fun. Well, this is fun because what do you observe here?
They have the same thing.
They are the same thing, just their signs are different. So what do you call them? They give us perfect square. We call them conjugates. When you multiply to conjugates, we get perfect squares. Difference of perfect squares. It means we take the first term square minus the second term square. That's all you have to do. If you're lazy like me, you don't have to do the FOILing method, just use perfect square method. What we get as a result is the square root and square cancel out. We get the number 13. And from 2 square, what do you have? 4. And what is 30 minus 4? 9. See, we could do it in 1 minute. Similarly, the next one. They're the exact same two things, just the signs are different. So we take the first term and the second term and square them. So 5 square root of 13 square minus 2 square. Now here you apply the exponent rule I taught you before. If you have AB to the power n, what do you have? A to the n, B to the n. That means this is 5 square and square root of 13 square. We didn't do that in the last example because we had only one term. We didn't have to worry about that. But now we have 2 terms, not 2 terms, 2 elements. One is 5 and one is radical. And this is 4. So we have 25 and 13 and 4. And then you multiply 25 and 13. 3 times 25 is 75. You put a placeholder. 1 times 25 is 25. And then you add them. 7 plus 5 is 12. So you put 2 down, but 1 goes up as an addition. So we get 3. So 325 minus 4, that gives us 321. That's it. If you don't remember or don't like the perfect square method, no problem. You can use your FOILing method. But keep in mind, final exam is 2 hours only, and you have to do 30 questions. So you should use all the shortcuts as shortcut as possible for every question you have. But you must show your work. So this is a shortcut with details work. We've done it multiplication. We did multiplication, addition, subtraction, simplification. Now the last thing we're going to do is division. Unfortunately, we don't know how to divide radical. So instead of dividing radical, we use a concept called rationalizing. Rationalizing means get rid of the thing you don't like. For example, if we have 1 over square root of 2, and you're trying to rationalize the denominator, it means do something so that the radical will not be on the denominator anymore. It will come on the numerator. Let's say you have square root of 2 over 3, and you're trying to rationalize the numerator. It means do something so that this radical will not be on the numerator. Instead, it will come down on the denominator. So that's how we divide radical. Because we don't know how to divide radical, we use the rationalizing concept. Why we do that, I'm going to tell you that another time. But let's do one example here. Something like this one. We are rationalizing the denominator. It means we don't want to see the square root on the denominator. Our goal is to erase that. Unfortunately, we cannot just take an erase and an erase them. It's not possible. We have to use some trick to erase that square root from the bottom, from the denominator. So let me rewrite square root of 3 and square root of 2. Our goal is to have only 2 without any radical. Can you think of a method what we can do so that the square root of 2 will become 2? Square. But we cannot just put square. In mathematics, in math, putting a power is impossible. What can you do so that we have a power? By the same thing. If you multiply by the same thing, we'll have a power and then we can cancel them. So I multiply this by square root of 2 as a result of the exact same 2 twice. They fight, and what they do? They die, and we have the 2. But you see, math is fair, right? We cannot just randomly multiply the denominator because we want to. If you multiply the denominator, what do you do? You must put it on the numerator. So we have square root of. Now when you multiply, you have the exact same radical. So can you multiply the inside? Multiplication has what? How many requirements? No. Multiplication is one requirement. Same radical. Addition and subtraction has two requirements. Same radical, same inside. In multiplication, as long as you have the same type of root, you're fine. You keep your root and you multiply the inside, so you get 6.
They both have right.
Yes. And now you're left. We don't care what you on the numerator, as long as the denominator doesn't have any roots. Because you're rationalizing the denominator, not the numerator. So the trick here is multiply by the same thing. So we have the power and the radical same number. Because when you're they are both of them are same, they cancel out. Take a look at the next one. Now we do a square root, right? What type of radical is this? Cube root. So what power we want so the cube root will cancel out? 3 power. So we want to have cube root of 7 3 times. This is what you want so that they cancel out and we get only 7. Now the question is, if you want the end result of 3 of them, how many more you need to multiply by 2 of them? So you multiply by cube root of 7, 2 of them. In order to cancel the cube root, what power you want? 3. But what power you have? What power do you have? Power. 1 of them. The power was here. Only 1 power. But you want 3 powers. So how many more you need? So that combining them, you have total 3 powers. 2 of them. They multiply top and bottom by 2 of them. The denominator is happy because they have 3 roots and 3 power cancel out. But what do you want the numerator? Leandra, question or answer? Question or answer? Which one?
Question.
Okay.
But this first. The green that you wrote, the powers from the outside, right? Not in the house.
As long as you have your radicals positive, you can either put them inside or put them outside. It doesn't matter. If it's positive.
And then the root 7 times the cube root of 7.
7 times. Now, if we have a power and radical at the same time, doesn't it look kind of weird?
Well,
It cannot cancel because this is cube root and this is square power. Yeah, but let's say I don't want to do that. I don't want to put in as an fraction power because my method doesn't want to do that. So instead, see, it looks weird, cube power and root at the same time. So let's bring this inside. We're allowed to do so because 7 is a positive number. So now what do we have inside? 7 squared is 49. Now, doesn't it look much nicer? Cube root of 49. So just to make it look nicer, we bring the power inside so that we have a whole number. But what happens to the 7? Cancel out. Huh? And our final answer is square root of 9.
Okay. So,
Maybe I'll put them as an extra credit. Yeah, this will be the next one. Yeah. There you go. This is Huh? I'm just gonna do more after the exam. So remember, we are going to do, you are going to do on Thursday, so don't miss the class. Except you. Yeah.
I had to do that. Now, when patients